here we go. Systems of linear equations and two variables. Fun stuff. Once we start getting into dealing with equations and looking at the properties of it and things that we can go through and do with them, we're going to be ending up dealing with more equations, more different types of functions, other things so that we can kind of get a ballpark idea of what's going on when we compare things. So now, really what we're going to take a look at here is a system of linear equations so that we can figure out where they are the same, where are they equal, what characteristics of them, what qualities of them we have. So, a couple of things to take a look at here. If I'm looking at what I've got for this one here, you'll notice that it says 3,000 x minus 72. Then it's got 5,800x minus 87. Two equations. Is it possible that these two equations at some point in time would actually be in the same place? Is there an opportunity for it to be above or below? Now this one starts at 72, that one starts at 86, right? If I take a look at these two equations that they have here, they got the blue line here, which happens to be the first one. They have the red line, which is the second one, and they do cross. So there are some characteristics of it that we can take a look at. So, let's take a look at this idea. A company is said to break even from the production and sale of a product if the total revenue equals the total cost. Does that make sense? I mean, if you're making a product, it's going to cost you to make the product, yes? And you get money when you sell that product, yes? And if you sell enough of the product to cover all your costs, you're broken even. Want to find the break even. So basically where we don't make any profit, but we've made enough to cover our expenses. So basically we're looking for the situation when R of x is equal to C of x. Now you're going to notice that by using function notation, we're able to go and identify what function we're talking about. Because I get over here with P, well, P of x is going to be equal to R of x minus C of x. Profit is equal to revenue minus cost. Basic ideas. Now, it says suppose a company has a total revenue given by this. So they've made, this is what they make in revenue when they sell a particular unit. Over here, this is what the cost of that particular unit is. Now you'll notice that there's a rather large number here and a small number here for the cost of each unit. Well, that's 61,000. Let's put it this way. Say you're going to, you want to get yourself a taco stand so that you can compete with Ufta Tacos. Okay? So you can park it over in a Kmart parking lot and compete with them, right? Are you going to have to spend some money to begin with in order to get that truck or that van, whatever you want to call it, cooler? Now, for every taco you sell, the 440, that could be ingredients that you got to have. That's going to be your cost of labor. That's going to be your cost of utilities. That's your cost of doing business for that, for one taco. But you make $440 off every taco you sell. Generally, we're not talking about tacos, are we? But you kind of get the idea of what's going on here. So, we can graph the revenue function, we can graph the cost function, and we can find the break-even, the intersection. Okay? You just simply put the two equations in. So, if I take a look at the graphs that I've got here, that means after we sell approximately 12 units. When we sell 12 units, we break even. That's a good thing, right? Evidently, it's definitely not tacos because people are not going to do. Oh, hold on a second. This company will break even on this product of 12,000 tons of the product are sold. So is it important to know exactly what our labels are? It's too as well. So, That is the easy way of doing it. Now, I will tell you this, that using a graph and trying to identify it by a graph isn't always going to work for you, because you're going to get fractions and decimals, and things aren't always nice. Real world data is not always nice. Now, granted, we can take the graphing calculator, we can have it do it for us, but you don't always have a graphing calculator. So what we're going to do is we are going to take a look at how we go through and solve a system of linear equations. So, there we go. Now, the idea that we're going to use for this is we're going to use this idea of what's called elimination. We want to get rid of variables that are in common. And one of the ways that we do this is by multiplying through by a value so that I get the same variable with the same coefficient but with opposite signs. So when I start off with this, there are at least two things I can think about getting rid of. I can either get rid of the x's or the y's. There's a better choice here. The y's are the better choice. And the reason is because you got a positive and a negative in front of the coefficients. If you are going to make mistakes when you're doing your math, it's generally when you're dealing with signs. So, what I am going to do is I am going to simply multiply the top through by a 5 and the bottom through by a 4. What this is going to do, it gives me 15x minus 20y is equal to 105. This gives me 8x plus 20y is equal to a negative 36. When I combine these equations together now, I am going to get an equation with one variable. So I put these together, 15 and 8 give me a wonderful 23x. These disappear. Let's see, 105 minus 36 gives me, oh, what is that, 69? Now, divide by 23, divide by 23, x is equal to 3. It does not matter which variable you choose. Just simply try and get the same variable with the same coefficient with opposite signs. Pick a number to multiply both equations through by. Sometimes you might only have to choose one. Sometimes you might have to do both. Worst case scenario is multiply by the coefficients of each one. No big deal. Now, if these would have been different numbers, maybe I would have gone for, oh, let's just say for the sake of example that this was an 8 down here instead of a 5. Well, then I would have just multiplied the top one by a 2. But the idea is same coefficient, same variable, opposite signs. Now, I can plug this into either one of these equations and solve for y, and I will get the exact same answer. It does not matter. So if I were to go and take 3 times 3 minus 4y is equal to 21, 9 minus 4y is equal to 21, subtract 9, subtract 9, I end up with negative 4y is equal to 12, divide by negative 4, divide by negative 4, and y is equal to negative 3. Okay? Good old algebra. What happens if I would have done it the other way? 2 times 3 plus 5y is equal to negative 9. Do that one. So I get 6 plus 5y is equal to negative 9. Subtract 6, subtract 6. Oops, sorry. 5y is equal to negative 15. And you can already figure that out. When you divide by 5, divide by 5, y is equal to negative 3. It will not matter which one you plug it into. It will just work. Now, the algebraic method of doing this is always going to be the more precise method. when dealing with real live numbers, you do this, you're going to get the best possible solution. You don't have to worry about looking at rounding or anything else like that. You'll have answers that will be in a rational form, and let's leave it there. So, let's go back to this. Now, there is another one that is called substitution. I'll show you that. Substitution is just simply that you are going to go and substitute something in for something else. Now, the nice thing is here that P is equal to 200 minus 2 cubed. P is equal to 60 plus 5 cubed. In this case, does P mean the same exact thing? When we were looking at this, were the y's the same things? Were the x's the same things? So when we're given a system of equations, x is the same, y is the same, p is the same, q is the same. So all I can really do here, make life easy for myself, is I can go and say, hey, 200 minus 2q is going to be equal to 60 plus 5q. Is that legal? Just a substitution. I replaced what p is equal to. Now, I've got one variable. Can I go through and solve? Oh, definitely. Let's see, how would I want to do this? Subtract 200, subtract 200, subtract 5q, subtract 5q, so I end up with negative 7q is equal to negative 140, divide by negative 7, 7, q is equal to 20. Now, does it matter which one I put it into? No. If I put it up over here, put 20, that's going to give me negative 40, right? So that would give me 160, yes? I put 20 in here, that gives me 100. 20 in there, sorry. That gives me 100. 100 plus 60 is 160. It doesn't matter. Whichever one you choose to plug it in. Now, when would I use substitution? When would I use the other system? If I got my equations looking like this, I'm going to use the system, okay? I am not going to try and go and solve for one of these variables and use a substitution. If I have a variable solved for something, that leads me to a substitution problem very easily, okay? Could have I applied my elimination method here? Yeah. It would have worked just as fine. That would work, but it would have worked. So, let's see. Now, they tell you to use substitution. Guess what you got to use? Substitution. That's just the way it is. Would I normally do this problem with substitution? No, I'd use elimination on this one, and I'd multiply the bottom equation through by a 2. Would that make sense to you? Because then I can get rid of the y's. It goes quicker. Can I do substitution? Yes. Solve for one of the variables. It's more work. I don't like doing it. Let's see. Got equations there. When should you use graph? When should you use any method? I'm talking about medication. One nurse has 2 solutions that contains different concentrations of certain medicines. It's a bucket problem. Okay? You guys done chemistry bucket problem? Take a look at the second. More often than not, it's not solving the equations that's the problem. It's if you don't have the equations, what are they? A nurse has 2 solutions that contain different concentrations of a certain medication. One is 12%, the other one is an 8%. How many cubic centimeters of each should she mix together to obtain 20 cc's of a 9% solution? And you're kind of like, well, okay. There's always going to be two situations here that you got to look at. One is the amount and the other one is a value. Now, it doesn't matter whether it's applied in this situation. You can apply it to money. You can apply it to a lot of different things. I've got two solutions, right? We'll call one solution X, and the other one is going to be solution Y. And how much of those two solutions must I have? Correct. Don't read into things too much. Always look at these and go, okay, what are they talking about? What are they talking about? Well, I got two things I got to put together. How much of it do I need? 20 cc's. Great. How much of the first one do I have? I've got 0.12x, correct? Plus, how much of the second one? 0.08y. And what's that supposed to be equal to? 0.09 of what? 20. Now this equation obviously can get simplified down to 0.12x plus 0.08y is going to be equal to, is it 18? Let's take 20 times 0.09. I can't do math this early anymore. So, now, I kind of ignore this equation right here. Just kind of push it. So, my question is going to be now, elimination or substitution? Which method would be the best way of dealing with this? Elimination indeed. Why? Because I got plain old x's, I got plain old y's. So, what I would probably do is multiply the top equation through by a specific number. And in this case, I'd probably go and take negative 0.08. You got 1.8? Wondering if anybody was going to catch that. Because the thing is, you were looking at 9%, right? 9% is close to 10. What's 10% of 20? 2. So how could 19 be that? You guys got to be aware of the values. Just because somebody goes and puts a bunch of numbers in front of you and says, this is what it's supposed to be. You should be able to take a look at their math and figure out if something's right or not. Okay? Math sense. Okay. So, that gives me negative 0.08x minus 0.08y is going to be equal to, this should be negative 1.6, yes? I got my decimal in the right spot now? Good. So now, what am I left with? Well, 0.04x is here. That disappears. And over here, I've got 0.2, correct? Divide by 0.04, divide by 0.04, and x is going to be equal to whatever that turns out to be. I think it's 8. What's the answer? What's 0.2 divided by 0.04? How much? 5. Now, do not let it bother you when you're dealing with decimals. Number isn't. You know that if it's a coefficient, you can divide both sides by it. You know that if it's a fraction, you can use the reciprocal. I can care less what the number is. I just need to know that it is a number and what to do with it. So if x is equal to 5, does that mean y is equal to 15? Well, x plus y is 20, correct? So if x has to be 5, this has to be 15 in order for it to work out, right? I wouldn't plug that into the other one. That other equation just flat out ugly. Take the easy one out. Why not, right? So, now I know exactly how much of each solution she needs, okay? You know how to deal with this. Don't let ugly things bother you. Don't let complicated things bother you. Simplify it down. This plus that gives me this. How much of this? How much of this? How much of this? So, dependent and inconsistent systems. Now, this is something you should put down in your notes somewhere, have access to, so that you can familiarize yourself with them. Intersecting lines have one unique solution, yes? Okay. Same lines, infinite number of solutions. Now, you can have the same equation in multiple forms. Say if I had x plus y is equal to 1 and I had 2x plus 2y is equal to 2. Same equation. It's going to give us the same answer. This is a dependent system. Okay? If you have two equations and they end up with the exact same solution, they simplify down the same thing. Same line, dependent, infinite number of solutions. Parallel lines will never have a solution. They are an inconsistent system. So A and B would be considered dependent. One has one solution, one has infinite solutions. So, now it says we're supposed to use the elimination method to solve these equations. So, if I go through and do these, and they have them there, this first one works out to be 0 is equal to 0. Is that true? 0 equal to 0. When this happens, this is going to be an infinite number of solutions. It's always going to be true. Now, obviously, if I got an x equal to something or a y equal to something, well, then I've got one solution. But if you work this out, and you get the same number on both sides, always true, infinite number of solutions. Now, when I go through and do B, I do the math, I say that 0 is equal to 24. Just because you get something like this doesn't mean that the equations are wrong. It just means that these are parallel lines. They will never intersect, so therefore there is no point in time that they will be equal. Therefore there is no solution. These are inconsistent. So, I do believe that is all I want to cover with you. This will be due at the end of class tomorrow. So, there you go. Have at it.